Hey guys, and welcome back to another YouTube video. So in today's video I'm actually going to be teaching you a really some of the math behind machine learning and neural nets actually. Now all of you would have already known, like, in neural nets there's this layer called the convolutional layer and a CNN. You would be knowing what a CNN is. It's what basically we use every day whenever you want to create a neural net. Now, here's the thing, how exactly does this CNN work? What exactly is this, like, take it, divide it into this thing called a kernel, take an entire image, divide it into these things called kernels, add some stuff like filters. What exactly, how do you actually calculate this stuff? So, that's what I will be going over through this video. The way it actually happens is through this thing called a dot product. That's what you will be looking at in this video, exactly what exactly is a dot product. Now, to actually understand what this thing that I just told you, a dot product, means, you need to understand another concept which is called a vector. Now, here's the thing, whenever you will be dealing with neural networks at a deep level, at a fundamental level, we will be using calculus and linear algebra throughout your coding process. You will need to have calculus as well as linear algebra under your belt. But in this video I am expecting that you know absolutely nothing what a vector is, how, all of the fundamentals of linear algebra as well as calculus. I'll be going over from scratch. All you need to know is just multiplication and addition, which obviously you all must be knowing. So, first of all, we need to pause and see what a vector actually is. Now, a vector is kind of interpreted in different ways by different people. So, a CS student or a computer science student can, one second, let me just, can interpret a vector like just some basic list containing values, a list or stuff like that. As you can see, something like that. And let me actually show you uh, through code what a computer science student can consider a vector to be. So let me just go into full screen mode. Alright, so what I am gonna do is I'm just going to quickly show you something what a vector can be. So if I have a list 4 5, a computer science student can interpret this as a vector, and a computer science student will be able to perform dot products. Now for that I will need to import numpy as np. I will also show you through the code how we can perform these dot products, so that's why. So this is how a computer science student can represent a vector. Not exactly, I know there are actually a specific command to create an actual vector, but over here I'm just talking about basically. So that's, we know that. Now a physicist, a physics student, will represent a vector with something which has a magnitude and a direction. To make so, if I want you to understand this better, imagine this kind of a thing like this coordinate system. Now I want you to like, this is the, actually let me use a different color so you guys can understand this a bit better. This is like the center point, this is the coordinate 0 and 0, and this is the x coordinate and the y coordinate. Okay, we know that. Now imagine some line that is kind of like scaling over here. This line has a magnitude and a direction because it's kind of like at a 45-degree angle approximately. This is 45 degrees, right? Like, it's approximately, it's 45 degrees, and this is exactly 90 degrees. So we know that much. All right, but here's the thing, how exactly will you represent this vector like this? Because this is how a CS student uses a vector, this is how a physicist will use vectors. So how do we actually represent an arrow as a like a list of numbers, and that's what we will be looking at. So first of all, what I will want you to now, you can see I'm getting kind of deep over here, but I really want you guys to understand what all of this stuff means, so you can actually take these concepts and actually apply them, because I really want you to understand neural nets at a really fundamental and a deep level. I don't want you to just know it kind of superficially. I want you to know it pretty deep. So now that we know that, what I want you to do is we will use the same kind of this coordinate thing that we were using previously. This is our x coordinate and this is our y coordinate, and like let's just assume that it's kind of like a scale. We have some stuff here and there. We have these, and obviously we can mark these things like this. Alright, now I know it's not very neat, but if this will be 1, this will be 2, 3. Let me actually now draw it again so you guys can understand it a lot better. um, Oops, I don't know why my drawing is so bad today. Alright, there we go. I think this was pretty cool. It was good. Alright, again let me just draw x and y coordinates. Now, if I draw a vector, now actually before I draw that vector, let me actually explain to you. So now what I want you to do is I want you to kind of like imagine two kind of like base vectors from where any kind of a vector will scale. Now it's really difficult to explain this stuff without you knowing linear algebra, so my explanations won't be really awesome, since we need to dive into linear algebra to actually understand what is going on. And I really don't like, I myself have just learned linear algebra. I'm no expert at it, so I really won't make any video series on it in the near future. Calculus, I think I will make one. So imagine two vectors which you kind of like from where all of the other vectors will come, and all of the other vectors will be kind of like shown with reference to these two vectors, and the vector are called the basis vectors. And the basis vector for the x coordinate, so the basis vector called the for the x coordinate is called the I hat basis vector, and one for the y coordinate is called the j hat basis vector. So this vector is gonna be called I hat, and this will be called j hat. Now I think this is not the way to represent them. I think we represent them like this, but I really don't know how to write this stuff, so that's why. So any vector that arises will kind of like be measured in terms of these vectors. So like if it covers 2 in I hat and 3 in j hat, it will be written like 2 3, and you can see that's basically how we represent a list of numbers that we have written over here, and a line which has a magnitude and a direction together, like kind of like a list, and we make it equal to like some line, kind of like by, and the way we basically are doing it is we are just representing the list as a coordinate system. Then what we are doing is we are let me just use some other color, defining our basis vectors. I'm gonna be just writing them as the I hat and the j hat. I think they are represented like this. We don't need a dot for I. We determine our basis vectors, we apply the basis vectors, and then we do it. Now the way you can calculate the dot product of two vectors, I really won't go into the dot products because I don't think I can explain it to you without actually knowing linear algebra, but I will tell you exactly how to compute the dot product. So given two vectors like 2 3 and 4 5, what will be the dot product of these two vectors? And the way we represent it is with this dot, and this dot I will just make it is for the dot product, oops, of these two vectors. So this multiplied by this. So the way we do it is, let me just rewrite this thing again. Dot 45. The way we do this is we type out do 2 times 4 plus 3 times 5, and we get it as 8 and 15. So now you know that this is kind of like the way we calculated dot product, and obviously we all know that 8 plus 15 is equal to 23. So you can see that when you multiply two vectors, 2 into 3 and 4 into 5, the dot product that you will end up with will be equal to 23. So that's basically how a dot product works. So now let me actually explain it to you a bit like symbolically, a bit like let me actually show it to you. So if I have two vectors, a, oops, if I have two vectors, a, okay, looks like there's something wrong with my drawing. A, B, dot, C, D, then the dot product will be AC plus BD. This is kind of like the formula for a dot product. And if you are representing this in 3D, so if you have like a cube and you are in that case the basis vectors will be I hat, j hat and k hat. So like there will be one and also in the y, the x, the y and the z. So that's the way the basis vectors will be. In that case, if it is like 1 2 3 and 4 5 6, I won't go and compute this, but the way it will be is we go 1 times 4, 2 times 5, 3 times 6, and then we will add up all of those answers and we get the answer. So that's basically what a dot product is, what a vector is, and that's basically what a CNN does. What a CNN does is it takes a kernel it with some values in it. So if you will just divide this stuff, it will have some values x, y, z, and you can also represent it with Greek letters star, psi, alpha, beta, gamma, delta, epsilon, zeta, you can all of that. And then what we do is we have some filters again with some rows and columns which we define containing some values, and we just find a dot product. And then what we end up with is we end up with an actual kind of like this answer. Then what we do is we apply a max pool or a average pool. That's up to us. We also can't apply anything. Or whatever max pool will do is it will grab the maximum value. In the average pool, what it will do is it will average all of the values and grab the value that we get. So that's kind of what happens in there. So now let's actually show or the convolutional layer through code. So what I'm gonna do is just a second. 1 second. Let me just get rid of all of this code. Aim, show roughly how a CNN, actually it will be a convolutional layer works. That's what we will be doing. So first of all, what we will need is we will need numpy. You will need numpy. You could do it without numpy, but that will mean that you will need to write a lot of code. So we will define two kind of lists. This will be 2 3, and we will add another list called B, and this will just be 4 5. We are, if you will see, we are actually using the example that we used over here. As you can see, we are using this one. So yeah, in this case also, that's what we are using. So we have 2, 3, 4, 5. Now what we will do is, one second. Alright, we will define another thing called C, and we will have it as np dot dot a comma b. And one second, let me just get out of this visual mode. Alright, then I am simply going to go ahead and print C, and now I'll just run this file. Let's see if I will be able to, because I haven't saved it. Python 3, what was the file name? I think it was main.py. Okay, it was test.py. Oops. Alright, let's see. Python 3 test.py. No, right. Oh, okay, I need to save this file first. And let's run it again. Python 3 test.py. And there we go. We get the answer 23, which we also ended up over here. So same ANS. So that means that our answer was correct. And that's kind of what a convolutional layer actually does. This is pretty simple Python code if you look at it. It's not something very, very complex. But this is kind of how a convolutional layer works. So basically the way you could actually do this is you could create like a class CNN, and then what you could have is something like a define underscore init underscore pass in a param. What you would want is the input A, which will be the kernel, and the filter. Then what you could do is you could just define the kernel as l.kernel is equals to kernel, and you could just pass it as a list. It's pretty simple. It's not at all complicated. Then you could just have a method which will just calculate the dot between the kernel and the filter, which is not that complicated. It's just the code that I showed you right now. So you can see, just by writing some basic code, not that advanced, and knowing the math behind this, you can basically make like kind of like a actual layer. And you can see, if I would try to explain you this same thing without the math, it would be almost impossible for you to actually visualize and understand what is going on. But in this case, since I actually showed you, told you what is actually going on under the hood, what is some of the math, not I didn't explain you all the math. I just explained to you dot products, and there's actually a ton of things that goes behind the hood. But just by explaining you a dot product, what it means, I was able to actually make you understand all of this stuff so easily. And I think even you guys would have understood this a lot better than just having the theoretical knowledge. So if you guys want to actually understand machine learning, neural networks, and all of this actually like cool things like quantum computing, you need to know the math. So you definitely learn the math and then give it a fresh approach, and I'm very sure that you will, that like what you will understand will be really important, and like whatever you will understand will be really clear. You will be really clear with whatever you get. So yeah, so I hope that you enjoyed this video. If you did, like and subscribe to the channel, and comment down below if I should make some more like just the purely math and then their code implementation videos. As you could see, this was not that long. We didn't even write any code, like we barely wrote any code, but I think you kind of understood what was going on. So that's it for today, guys. I hope that you enjoyed the video. This wasn't some very, very long video. It was still 20 minutes, but until the next time we meet, bye bye.